my Java implementation of highest card array. Welcome to CS 1401 Video 10.2, which is about iterating over arrays. In the previous video, I presented the data structure array, which we can think of as a table where each entry in the table has an index and a value. In this video, I add iteration as a programming technique for arrays. Much in the same way that I used arrays to simplify the algorithm for providing the name of a month, I can use iteration to radically simplify the algorithm for finding the highest card in a poker hand. You'll recall that in the video on conditionals, I presented an algorithm in which I assigned the variable highest card the value of the first card, and then compared the value of highest card with each of the remaining 4 cards. And if one of those cards was higher than the current highest card, I put that value in the highest card. Here's the algorithm I had for highest card, and you'll note that it had 4 comparison tests. Here's a simpler algorithm using iteration to solve the same problem. So again, I put the first card, that's card 0, in the highest card. I set up an array with the rest of the values, that is cards 2, 3, 4, and 5, which I'm calling here card 1, card 2, card 3, and card 4 because my index numbers will start at 0. And now here's the heart of the algorithm where the comparisons happen. It's going to be a for loop, and it will start with I being equal to 0. It will loop as long as I is less than 4, and every time it completes the loop, it will increment I by 1. And here's the comparison. If card sub I, that's the card we're looking at now, is bigger than the highest card, then assign the value of card sub I to the highest card. And then after the loop is over, I just return the highest card. And that's the entire algorithm. Much simpler. Here's the Java implementation of the highest card array algorithm. The first 5 or 6 lines are simply getting the input from the command line and setting up the array. In most programs, it will be much simpler, and we'll learn how to get input from a text file shortly. In the meantime, I'm going to put the first argument from the command line into the highest card. I'll put the subsequent cards into card 1 through card 4, and then I'll put card 1 through card 4 into an array of length 4 called card. In other words, card 1 will be in the array element with index 0, card 2 will be in the array element with index 1, and so forth. And now we come to the heart of the algorithm, the for loop. So we'll iterate the index of the cards from 0 through 3, and each time we execute the body of the loop, we'll check to see if the card in the array position I is greater than the highest card we currently have. If that's true, then we'll assign that current card I to the variable the highest card and continue to iterate until we've looked at all 4 cards. We know that at the end of the loop, the variable the highest card must contain the biggest value of all 5 cards, and so we'll print out the highest card is and that value. To test my Java implementation of highest card array, I'll compile it, and then I'll test it with 3 different orders of 5 cards. The first will be in ascending order, and when I run it, I get out the highest card. Next, I'll try it where the highest card is the first card, and the program gives me 10 as the highest card again. And now I'll put the highest card in the middle, and the program correctly reports that 10 is still the highest card. An array has fixed size, so my array card has size 4, but we can define arrays that are pretty much as large as we want. This means that we now have the means to implement the algorithm for finding the shortest person in the room, which I discussed in the video about algorithms. And we can do this for even very large rooms. I'll generalize the problem to that of finding the lowest number in an array. Here's the algorithm. My algorithm is called lowest, and it's going to assign to an array some set of integers. The first element in the array I'll assign to a variable called best, which is the lowest value we found so far. And then I'll iterate across the rest of the array. That is, I'll start with index 1 instead of index 0. I'll iterate as long as the index is less than the length of the array. And each time I loop, I'll increment by 1. If the value of the current number we're looking at is less than best, then that's our new lowest value, and I'll assign that value, number sub I, to best. And when the loop is done, I'll print best, which will be the lowest number of the entire array. And here's an implementation of the algorithm lowest in Java. I've called this implementation lowest n because I'll be using the name lowest for an improved version next. Here's the code. I'll initialize an array of numbers, and when I initialize an array in this way, it automatically sets the size of the array to the number of elements in the list of elements between the curly braces. Next, I'll assign the value in numbers sub 0, that is the first element of the array, to the variable best, which will represent the lowest value so far. Then I'll iterate through the remaining elements of the array. So the index I will start at 1. I'll continue to iterate as long as I is less than the size of the array, because that way the last value of I will be the index of the last element in the array. And on each iteration that is within the body of the loop, if the element of the array sub I is less than our current best, then I'll assign that new lowest value to best. That way, after I've iterated through all of the elements of the array, I'll know that the value in best will be the lowest number in the array, and I can print out that lowest value. Let's compile my program lowest n, and now I can run it. And sure enough, it prints out -15, which is the lowest value in the array of integers that we searched. My program lowest n initializes the array of integers by simply assigning particular values to the array elements. But that means that every time I want to check a different set of array elements, I'd have to rewrite my program. It would be more useful to be able to find the lowest value of any set of integer values without having to rewrite the program. Here's an improved implementation that reads in the integers to check from a text file, and I'll call that file nums.txt. My new improved algorithm is called lowest. The program begins by importing two utilities. First, the scanner, which we've already used, and second, the utility java.io.file. IO stands for input-output, and that is a utility that will help us read from a file. So, I begin by creating a new scanner, and this time the scanner is going to take input from a file rather than from the terminal. Next, I create a new array of integers of size 100. Note that I'm explicitly saying how big the array should be. In our previous examples, the size of the array was determined by the number of values that we used to initialize it. But in this case, we're reading values from a file, and we don't know how many values there are going to be, although we're assuming there are going to be 100 or fewer. The variable size is an int, which will count the integers as we read them in from the file. And while the file has another integer to read, I will assign it to the array element at value size. So size starts out at 0, so the first integer in the file will get assigned to number sub 0. And every time I execute the loop, I increment size by 1, and by the time I've read in all the integers, size will be the number of integers in the entire file. And by the time the for loop terminates, best will be the value of the lowest number in the file. So the program ends by printing out best, which is the lowest number in the file. I'll compile lowest and now run it. And sure enough, as expected, it prints out -15, which is the lowest value in the file. The program lowest returns the lowest integer in the text file which we read. With a really simple change, I can create a new program called highest that returns the highest value in the array. All I need to do, in addition to changing the name of the program, is to change one character. And that's the test for which is smallest. I'll just change it to which is bigger, and now best will start off being considered as the highest, and we'll iterate through the values in the array, and every time we come across a higher value, we'll put that in best, until at the end we'll have the highest value in the entire array, and we'll print that out. I'll compile highest, run it, and sure enough, it prints out the obviously highest value in the text file which we looked at. In this video, we've looked at iterating over arrays both in pseudocode and as implemented in Java. We've also seen how to read integer values from a file. In the next video, I'll discuss how to use iteration, especially for loops, to do some other useful things with arrays. See you shortly.